Our project is the transporter. It's designed to compete in the 2015 ASME Student Design Competition. The objective is to design a remote-controlled ground vehicle capable of delivering water, food, and medicine to sites of natural disaster. In order to do that, the transporter must be able to overcome obstacles and withstand various loading conditions. The chassis houses the electronics and other mechanical components, therefore it is critical that it doesn't fail on its mission. 6 studies are done on the chassis to test if our initial design fails. In this video, 4 of them are explained. Statics. Nonlinear static study is performed on the chassis due to nonlinearity in the APS plastic. The 3 loading cases tested are standard and incline loading and front impact. The initial design of the chassis yields when the load is increased by 150% from intended use. In our next design iteration, we added supports to the location of high stresses and increased the wall thickness to prevent the material from yielding. Buckling. Under compressive loading, the chassis can buckle globally as a square hollow column, and its sidewalls can also each buckle locally as thin plates. The result from the buckling test, however, shows a buckling load factor of greater than 1. Which means the chassis will not buckle, and yielding will also more likely to occur than buckling. Frequency. The minimum resonance frequency is at 99 Hz. If all the motors are mounted on the chassis tightly, it's not possible for vibrations to occur at that frequency. Thermal. When the transporter stalls, rather than being converted into mechanical power, the electrical power input is converted into heat by the motor. Each motor generates 12 watt of heat during stall, transferred it to the chassis via conduction, and the chassis then dissipates it through natural convection on all its exposed surfaces. Steady-state temperature is above the material's melting point, but the transient study shows that it takes over 30 minutes to reach its melting point. It takes even longer to reach steady-state temperature. The chassis does not fail the test because stalling for 30 minutes is far from its intended use.